I think we're off to a great start, don't you? Definitely sets the tone for the rest of the day. And we are quickly moving on to a panel discussion, similar to climate change and indeed problems on Earth, but specifically more on how space technology can help solve those problems. Now, this panel discussion will be led by Sebastian Toupy, so not really a big role for me. Sebastian, are you there?
I am there, indeed.
Hi, good morning. How are you?
I'm very good. What about you?
I'm good, thank you. I'm in a very nice setting, so it's a great environment to be in. Where are you calling in from today, Sebastian?
I am in Amsterdam as well, actually.
So you're close by.
I am indeed.
Nice. So Sebastian, you'll be leading the panel on solving Earth's challenges by using space technology. I would mostly just like to give the floor to you to further introduce yourself in the panel. And just as a reminder, also this time you can ask any questions you might have in the Q&A, and Sebastian will be more than happy to look into them. Sebastian, enjoy the panel.
Thank you very much. All right. Well, good morning and welcome, everyone. And thank you for the Tech for Good conference for placing space tech at the center of this impact question. I'm really excited for the discussion that's coming. I think that space tech has really come a long way since the first takeoff into outer space. And while many companies like SpaceX, Virgin Galactic, or Blue Origins are making the headlines, there's many other interesting developments taking place that we'll touch upon today with our panelists. And so before we get started, I'd like to welcome the 4 experts that will help us to actually explore this fascinating topic. And the first person I'd like to introduce is you, Alexander. So Alexander Gunkel is founder at Space for Good, and he's built a geospatial innovation lab that uses satellite Earth observation to monitor impact initiative. Alex, can you tell us just a little bit more about yourself and what has brought you to launch Space for Good?
Yeah. Hey, Sebastian. Hey, everyone else. Really excited to be here. Thank you for the invitation and for this platform. So maybe first a quick explainer of what we're actually doing with Space for Good. So Space for Good works with satellite Earth observation to what we call map and track social and environmental impacts. For example, we detect illegal logging in Southeast Asia. We help cities like the city of Rotterdam in planning more sustainable urban development programs, but we're also helping on flooding events, for example, through flooding extent monitoring in North Africa. So our applications are quite broad, and usually we're providing insights which are then being used by local change maker to make more informed and faster decisions on site. And, besides developing our own applications, our own platforms, we're actually doing quite a bit on training, capacity building, so also enabled and NGOs, other social enterprises, and also local governments in making use of Earth observation data analytics, as well as a lot of startups. But to come to your question of how the whole thing started, I myself studied engineering and business administration and started my career at the European Space Agency here in the Netherlands. And while the work I've been doing there as a project review analyst was super insightful, I realized, it's kind of reviewing others people's work. And I somehow had this drive, okay, I would like to do something more action-oriented. I would like to get my hands dirty. And through this program with the European Space Agency, I got to know about the Technology Transfer Office and the European Space Agency Business Incubator. And that allowed me to co-found my first company called Skytree, where we actually, funny enough, also worked on the topic of carbon capture, so carbon capture and utilization. But at this point, at least, I had more my engineering hat on of saying, hey, that's such a cool technology, absorbing CO2 from the air and trying to come up with this carbon neutral or even carbon negative applications. How can we develop this further? How can we commercialize this? And that was the driver for me for the first 3-4 years. But throughout this process, I actually connected much more with the impact community, starting with being a member from the Impact Hub here in Amsterdam, which is actually a global community all around the world. So just a shout out to them, plus an invite to all the participants to check it out and maybe also become a member. So I started figuring out, okay, why am I doing this? And then the topic came much more, okay, it's about driving change and creating impact at a large scale and actually as fast as possible. And being part of your incubator and accelerators, I saw particularly a lot of data and service companies just kind of shooting through the roof, being able to scale really fast. And I was kind of thinking, okay, how can we do something similar? But maybe not driven by profit goals, but impact goals. And that's where this idea of, okay, how can I bundle all my activities around space technology and sustainability in an entrepreneurial manner? And kind of do a step forward and do a step forward faster. And that's how Space for Good, basically, as an organization, advanced. And since then has been growing constantly.
Okay, really exciting. Well, I'm looking forward to diving a little bit more later into some of the applications that you've seen and some of the work that you've been doing at Space for Good. So thank you, Alexander. The next panelist that I'd like to welcome to the stage today is Parya Pasha Zadeh, who is project officer and the Geoinformation Science and Earth Observation faculty at the University of Twente. So Parya, could you share a little bit with us about your work at the university and the bridges that you're building between sort of this theoretical and applied research in the space sector?
Thank you so much, Sebastian. Hi, everyone. First of all, I got rid of the background to be unified with everyone else. Very happy to be here, very excited to be a part of this discussion, and super happy that we could manage to have space in the center of the attention. Well, as you mentioned, I work at ITC Faculty of Geoinformation Science and Earth Observation. What we do in this faculty is that we take geoinformation and Earth observation and we apply it in different domains, from water resources management to natural resources management, disaster resilience, urban planning, and basically anything else that you can think of. My role in the faculty at the moment is a project officer, but I've also been a student there when I did my master's. And I was a lecturer there for 6 years. And now what I do is I provide support to the scientific staff to apply for grants and get more projects in for the university. These projects can be capacity development projects like trainings or courses or double degrees, or they can be research grants. So we get money and PhDs to do more research, or they could also be partnerships with private sector or partnerships with NGOs, with different organizations, co-create solutions or do something more than just staying in our own faculty. So that's pretty much my role at the moment over there. And I'm sure I'm going to talk more about what I do in detail.
Absolutely. Thank you for that introduction. Great. So really excited. Now I'd like to welcome Cornelius Wicks, who is Director and Solution Architect at Head of Communications and a committee member of the Global Science and Innovation Smart Cities World. So Cornelius, can you tell us a little bit about what you do at Head Communications and what pushed you to launch that company from previously being an instructor pilot? Is that correct?
Yes. Good morning, everyone. I'm Cornelius Wicks. Good morning, Sebastian and panelists and audience. Yes, thank you. I am Director of Head Communications, which is based in the Netherlands. And in my former life, so to speak, I was indeed an instructor pilot for the U.S. Air Force after having grown up in a city that in Pittsburgh, Pennsylvania, a city with an economic downturn. There weren't a lot of educational opportunities or a lot of employment opportunities. So I went on to the Air Force to become an instructor pilot. And in flying, in aviation, one of the most interesting natural phenomena that we have in the universe is space-time. And in order to be successful in aviation, we are dependent on space-time. For example, when two aircraft have to meet at a certain location for an air-to-air refueling or a rendezvous or so, they have to meet in a specific location, a specific point in space, at a specific time. And a quote that comes from the director of the Hayden University, the New York Science Center, Neil deGrasse Tyson, always says, you have never met someone at a time without meeting them at a certain location, at a certain point in space. Conversely, you have never met someone at a location without meeting them at a specific time. And this very inspiring quote really got me thinking about everything that we do in our work in aviation, in smart cities, and so forth, is dependent on this, dependent on space-time. And I was very inspired by this because in my work, when we tested new aircraft with new different types of sensors and so forth for natural disasters, for hurricanes and so forth, these are high precision instruments that are data dependent. So you have to send a large volume of data from the observation from the aircraft down to a ground station or down to a weather ship or some other location. And this was always a burden to us because sometimes we had to fly longer and sit until the data burst reached its destination. It cost a lot of money, a lot of time, and a lot of hassle. So I saw a niche in the market. I thought, okay, if we're going towards automation where we're going to have drones for logistics and we're going to have robots for inspections, that's also a large volume of command and control data. So that inspired me to start Head Communications, and we have now a number of patents for super high lossless data using our number one product called BLOS, Beyond Line of Sight, where we can monitor an entire fleet of drones, for example, in a logistics network in real time and be able to control all of those drones, pass that information to air traffic control and so forth. We have broadened our scope because of the regulations of drones, and Europe has been limited. We have broadened the scope to smart cities. So I asked the question, how can I use this technology to make cities smarter? Because that also is data dependent. Now, one step further, it's not just about the technology in the cities, and COVID-19 has shown us that it is important to make a city smarter. It's about what we do, what that city can mean to its citizens, how the city can give the citizens a better day. So now we have a number of services that we are using to make cities smarter, and I was recently involved in the World Business Angels Investment Forum's Science and Technology Committee to address this worldwide. And so that's kind of in a nutshell where we're at. We work in Africa, we work in the US, we provide logistics networks, high-speed data for logistics networks. In Ghana, a multimodal logistics network with a drone company that delivers medicine to remote areas and so forth. And in the States, we work with energy companies and so forth. And that. So that's kind of my journey and kind of how it started.
That's great. I guess a multi-step journey, right, with a lot of really exciting developments, and I think really curious to see how we can touch upon some of the later applications that you've discussed here towards the end, a bit later in this discussion. So welcome, Cornelius. And last but not least, I'd like to introduce Angela Sindic to the stage. So Angela is co-founder of Marmoris. She's an AI specialist who analyzes satellite data to track ocean sedimentation, which can be a threat to coral reefs. So Angela, as a senior software engineer who sort of switched her career to tackle a pretty painful problem, can you tell us a little bit about your work at Marmoris and the scale of the problem that you're trying to solve?
Yes, sure, of course. Good morning, everyone. Nice to speak here in this forum. Yeah, I'm a software engineer by nature, and I love to have my hands dirty in the code. And the nice thing about my profession is that you can work with different domains like payment industry, like logistic. And also I have the opportunity to work for Marmoris, where we tackle environmental problem and trying to solve it with AI in combination and using satellite data. And at the moment at Marmoris, we focus on the coastal habitats and support them and make decision-based programs to enable decision makers to make smart decisions. And we are focusing on the coral reefs because we think that coral reefs at the moment are the most dangerous habit that exist. Almost 50% of the corals are dead at the moment, and if we don't stop the climate change and the water warming and the heat waves it produces, it will go on like this. And on 2050, roundabout, almost all corals have died if we don't change something. And why is that important for us? The coral reefs are also very important for coastal protection. They're a source of food. A lot of fishes breed there and start their lives. And it's very important to do something now, because if we don't do something now, it's too late. So we have to be very efficient and very effective with our solutions. And I think that's the most motivating thing, that space technology in combination with AI can make difference and point to the most relevant problems and provide insightful insights that can lead into actionable actions. At Marmoris at the moment, we use space technology, and especially water indicators like turbidity that affect coral reef ecosystems. And you can measure it from space indeed. And I'm busy with analyzing the turbidity of the water. The turbidity is a problem for the corals for different reasons, but one of the reasons is that the sedimentation maybe covers the corals and they cannot survive anymore. So that's a main focus at the moment, and we will also add other features as well.
Great. Well, thank you for that intro. I will come back to that in a little bit later, because when I first heard about this, I thought it was A, fascinating, and B, I didn't really see the correlation between space data and then the coral reef straight away. So I'm looking forward to dive into that a little bit later in the conversation. But thank you very much all for being with us today. I'm really, really excited to sort of the discussion that we're going to have in the next 30 minutes, where we're going to try to answer this big question, which is, can space technology help us solve some of our most burning challenges on Earth, and how we can use some of the applications that you've all sort of touched upon, or that you're working in your respective organizations to be able to solve some of those challenges that we're facing on Earth. Before we dive into all the specific applications, I'd like to sort of start off with leveling the playing field a little bit, right? And maybe start off with you, Cornelius. If you can help us to zoom out a little bit in order for everybody in the audience to understand the broad term of space tech and what we really mean when we talk about space tech, because it's a pretty broad term, and I'd like to sort of like scope it out a little bit.
So indeed, space tech is indeed very broad. The space agencies, European Space Agency, ESA, and also NASA, and now some of the others that are converging in on the space sector, identify these in three categories. Human space flight, so everything to do with sending humans into space, doing all kinds of experiments, doing research and exploration. The second is telecommunications, satellite systems that are sent into the orbit from the recent SpaceX Falcon Heavy, the Iridium satellite constellation for providing satellite telecommunications, satellite broadband, and so for low Earth orbit satellites. And the third pillar in space technology is Earth observation. So everything to do with monitoring crops, monitoring flood areas, such as quality of crops, wildfires, and everything to do with what's going on Earth observation. We also have GNSS, which is the global navigation system. The recent launch of Galileo has provided more accurate positioning. And so those four items provide us with things that were developed by all the space agencies and so in the space sector for our solutions. So that's in a nutshell what space tech means for us is being able to utilize that expertise and those things that have been developed, such as materials for space, such as telecommunications and GNSS, to make our products better, to make our processes, business processes better. And there's a larger opportunity, a growing opportunity in the space sector through the commercialization of the space sector as well.
Yeah, absolutely. Like, thank you for those precisions. I think it helps a little bit. Like, I was having a discussion with someone who is working with a lot of entities around ESA, particularly here in Europe, that was sharing the fact that even though most people picture SpaceTech with the big NASA logo out there, there's over 150 organizations that work in the SpaceTech sector in Europe alone, making it one of the biggest markets for sort of development in space technology, which I think is fascinating and unknown by most people, even within the tech sector in general, just how big and how many opportunities there are there. Parya, I would like to touch upon a little bit more the work that you do now. And we've just discussed satellite, and everybody talks about data and analyzing what's happening on Earth. Satellite data is in the news a lot these days, but it can be a bit difficult to differentiate what sort of science fiction versus things that are actual research. And I know that you sort of act as this bridge at the university between entrepreneurship and academia. So could you help us to sort of shed some light a little bit on what the space tech researchers are working on, and what are sort of the practical applications that we can expect from universities?
I can try. The thing is, SpaceTech, as you just mentioned, it's so broad, and there are so many different elements to technology that some of them for me are still sci-fi. Like if I listen to a presentation about, upstream about the sensors specification or the satellite specifications, for me, that's still sci-fi. But I can talk on and on about the observations that you can make with satellite data and how can you use those observations. Because when we're talking about satellite data, it could be different things from navigation to images, just like that green-blue images, to like radar, that is something like the way that bats see, by sending signals and getting back and figuring out the distance. So that's a different type of sensors. Then we have multispectral and hyperspectral sensors that they see much more than the human eye can see. And based on the different things that you can capture on the ground, you can obtain different characteristics of different phenomena on Earth as well. So indeed, you can do so much with satellite data. But at the end, we also have to always mention it to the people that it's not a holy grail. It's a great pointer. It's a great warning system, monitoring system. I can get quite a bit of information with it, but it's not like solving everything. But some of the, there are the common things that I think are a little bit more paid attention to, like agricultural uses for satellite information. So you can delineate the crop fields, you can see what grows where, you can monitor land degradation, you can monitor deforestation, you can see how the coastal zone is changing, you can see sedimentation in the water. So these are the things that you can watch happening on the floor. But then it's not just looking, it's also analyzing the data through space and time. So you can also see how certain thing has been changing time. Is there a pattern? Is there something that you can do to change it? You have to take action now based on what you can study. But then there are some cool stuff as well that are more like newsworthy, such as counting elephants roaming around in Africa, for instance. That's something that recently has been done using very high resolution satellite imagery. They can really count the number of elephants, individual elephants, better than even doing it manually, like going to the field and counting them. But at the moment, I think the research is really focused on using artificial intelligence and cloud computing for satellite data, because data is available at immense scales, and the AI is also quite advanced for getting information out of this data. So scientists are at the moment trying to put together the most efficient ways to have fast, accurate and big analysis happening for different application domains. And I think that's it. And you also say, how does that connect to the private sector or the entrepreneurship, right? It's not just research for the sake of doing research, because if you're doing that, then you're doing something wrong. So what happens is, when you develop a new algorithm that can classify your image with higher accuracy, or an algorithm that can detect individual objects better and more efficient, then it has to go also to the private sector partners or somebody who implements it in a larger scale and makes sure that it reaches to the end user, so that somebody is actually going to use what we are generating. Because otherwise, data and technology are only as good as they are useful to the user.
Absolutely, and I think we'll definitely touch upon that a little bit later with Alexander and Cornelius as well. But yeah, thank you for sharing a little bit about what's going on at the moment there and what you've seen. I love the comment about the sort of usefulness of that data, and that's definitely something that we'll come back to. Angela, I'd like to come back to you now. Like you mentioned in your introduction some of the work that you're doing with Marmoris, but particularly the fact that there's many challenges that we're facing as a society, and that the ocean is sort of the origin and engine of life on this planet ultimately, which is something that at the moment is in pretty great danger. You've talked about warming waters, but then pollution, ocean acidification, overfishing, all of those things that basically influence the health of the ocean currently, which then leads to the physical destruction of some of the coral that we have around the world. Like, can you tell us a little bit about what you're doing at Marmoris to sort of try to analyze that and see what's going on around the coral?
Yeah, sure. At the moment at Marmoris, we focus on coral reefs, but the things we are developing can be transferred to other coastal environments. And at the moment, as I said, we focus on water indicators. For example, the sedimentation is one of them. So you can measure the turbidity of the water with optical sensors and then derive the turbidity from that. And with that feature, you can kind of do all kinds of analysis, like hotspots analysis. Where are the regions that are affected by sedimentations the most? Where are regions that are not affected? And also with this satellite data, it's so nice. For instance, we use Sentinel-2 data, which has a pretty high resolution, like 10 by 10 meters, and also has a consistent time frame. You can go back in time and do time series analysis and also analyze the trends that are you would expect, and also do some forecasts and use it for alerting systems and things like that. So with only one tiny parameter, you can almost do such huge things that have really the user in the field. For example, for coral restoration, it's important where to look localize or where to put those small baby corals they want to replant. And it's not a good idea to plant them in a location where a lot of sedimentation is going on. And also the sedimentation is a proxy for pollution. So yeah, it's also an indication when there's a trend upwards, that's also not a good idea to choose that region which has that effect. So there's a lot of ideas. I like this. You can be so creative with this combination with AI, satellite data, massive data. It's a huge source and apply it to a domain, but it really needs help and you really see the impact. So yeah.
I can only imagine how much of a game changer it is seeing the excitement you have to talk about what you can do with that satellite data, which I think is quite brilliant. I have heard that you came up with this idea during a hackathon. Can you tell us a little bit more about that?
Yeah, I like hackathon. I like coding still. After 20 years in the business, I like it very much. And I met my other two girls, and when we found we make such a nice team, we also got so interested and so catched by the idea to do something for coral reef. So at the hackathon, they brought us together with an engineer from Costa Rica, and they had a specific problem that we can solve with satellite data. So we worked as a team for that hackathon. We won that hackathon, and then we applied for other things, and we decided to found a startup, and that's where all it began. So. Yeah, hackathons are nice. You can meet very interesting people.
Well, I think that's a big inspiration for all the people that are joining the hackathon that's organized by, the Tech for Good conference, that anything's possible and you can actually build some pretty exciting projects on the back of just a weekend. Thank you for that, Angela. I mean, it's pretty great application of sort of space data. And I would like to dig into a little bit more of those applications. I think, Alexander, you've seen more than most at Space for Good. Can you tell us a little bit about, some projects that have caught your attention or that particularly excite you as part of what you're doing at Space for Good? Oh, I think you might be muted.
Yeah, right. Sure, I can. And, I also would like to take a step back, because now we've been speaking about Earth observation a lot, but actually it's kind of a new space era, kind of a new space race. We also refer to it Space 2.0. So it's not just about like new data sources, but it's also about new material developments, for which you can use for shielding, which, as mentioned beforehand, like you develop materials which can actually absorb carbon, CO2 from the air in order to concentrate and sequester, and all those innovations are being developed for space, and some of them even in space. Like you have to think about healthcare, like medicines being actually designed in microgravity in order to form very new attributes and characteristics. You're speaking about new possibilities of satellite connectivity to suddenly give you fast internet all around us, the world, in areas which didn't have any access to internet beforehand. We're speaking about cheaper launching, basically the development of rockets and engines which can shoot up satellites for a fraction of the cost, like 10% of the cost, much faster. And we're also speaking about new kind of satellites which now can be actually developed with very small teams instead of having like big prime contractors. Now suddenly universities and even startups can develop satellites, and so there's a lot of technology innovation happening, but there's also a lot of like business model innovation happening as well. For example, an example on launchers. Now we have companies which offer launcher as a service, where you just kind of tell them what you would like to have launched, and they just figure out everything for you. Or microgravity as a service, like if you're like a medicine developer, or if you're just a tourist and you would like to experience microgravity, now you have a one-stop shop for experiencing. And that not only has to do with technology, but it also has to do with services. Of course, what keeps us busy within Space for Good is Earth observation. So I would just kind of emphasize a little bit more of what excites me there in particular. And a recent term and buzzword which emerges not only in the space sector is actually digital twins. So you might have heard about this on engines to kind of calculate when your car engine or industrial turbines need to be replaced, by just having a better insight in what is happening near real time, what we call like nowcasting, in order to do predictions. And now actually and it's led by actually a European consortia around European Space Agency, European Commission, and a lot of other universities and NGOs and enterprises. The term of digital twin Earth emerged. So imagine you would have Earth as a digital twin. And this is such a mind-blowing concept of saying, hey, could we anticipate, like understand what's happening on the global scale, like in the past, but also right now. And why do we want to understand those things? So we can understand the future, we can understand the scenarios, we can understand what happens if we do that, or what happens if we do that. So we can create scenarios based on this. So this topic of digital twin Earth is highly fascinating, and it already implies this global challenge will also require kind of global collaboration. Because there's going to not be any Skynet which will be able to do everything on that. No, it requires all these different local research institutions, all these local NGOs, local governments, but also local startups, to be able to focus on one particular challenge, on whether it's on water management, whether it's on sand theft, whether it's on wildlife monitoring. And again, you have to break it down even more. You have to look into different ecoregions, because if we do something here in the Netherlands, it will not be directly applicable if you go to Namibia or if you go to Sri Lanka. So the challenge is, or let's put it the other way around, the opportunity is to actually like bring all these players together, which have this contextual understanding, but also understand how to work with geoinformation and make use of satellite Earth observation for that. And indeed, that's not something what you can do yourself. And I think that's where new collaboration models have to emerge and are actually emerging. And, here actually in this panel, you already have quite a nice representation of that. Because, for example, at Space for Good, we were thinking about, okay, how can we really maximize the impact of Earth observation and geospatial information? And we said, okay, we can't develop everything ourselves. That's just not possible. And that's also not desirable. So how can we create platforms? How can we to collaborate. And we realized, okay, one way of doing so is capacity building and just getting problems and problem solvers together. And actually, the hackathon Angela was speaking of, where the initial idea of the company emerged, was organized, co-organized of Space for Good, where we helped those teams to connect, for example, then with this Coral Reef NGO, and pointed them towards a few other possibilities of bringing this further. And look, now suddenly like a company emerged from that, while Space for Good now starts building up stronger relationships with the Twente University, where we have then Parya as our contact point. So suddenly, like we creating our own geospatial innovation ecosystem, kind of working towards shared goals. And I think that's what really inspires me.
That's really incredible. And I'm glad to see that it's sort of already happening and not just a discussion where you think that in a few years, that might come. It's already taking place. Where do you see sort of the biggest avenues for stronger collaborations that's not currently the case?
I think that there's so many. But what I would be most passionate about is purpose-driven small companies come together, because I think we have to have two things in mind. The clock is ticking. Like we don't have a lot of time in the first place. I mean, there's not generations to build an empire anymore. Actually, like with notions like that, we only have 60 harvests left. Then it's not about like who's getting the biggest share of the pie, but how do we make sure that anybody of us still has something to eat on that end. So I think there needs to be this understanding of that there's a pressure of all of us to do something and do so together. So yeah, maybe that's actually the core message on that end.
Great. No, thanks for that. And I'd like to explore a little bit of a different sort of part on the collaboration side that you've just touched upon. And Cornelius, as a member of STI and sort of the smart cities of the world, how do you sort of see collaborations with maybe not sort of all the private sector, but with NGOs, with universities, with public authorities, and sort of other social enterprises to actually be able to get to this sort of more sustainable planet and society?
Yes, Sebastian, indeed. And it's nice you asked that question, because now there's that very question is being asked on a larger scale within STI, but also within the educational sector as a whole. We're seeing recently the limits of education and limits that COVID-19 has imposed on education. Boris Johnson, the Prime Minister of the UK, says, okay, now we're opened up. We're going to have a skills revolution. We're going to make Britain smarter. Joe Biden, the President of the United States, the same thing. We're going to strengthen the position of the United States through skill building. And so the Netherlands has recently allocated 1.2 billion by Premier Mark Rutte for education in the Netherlands to strengthen education from kindergarten all the way up to university. So, and at the same time, we have this convergent evolution of the space sector, where there are more parties being involved, there are more stakeholders. But what's still missing, and this is a discussion we have in the World Business Angels Investment Forum, what's missing is the fact that there is a great opportunity that's not being rewarded, and that's for commercial companies, startups, entrepreneurs, and so to engage in education models, revenue models for education, commercial models for education, commercializing education, distributing the opportunities of education over a wider scale so that kids don't get left behind when the school is locked down. And this is something that the space sector can do. The space sector can bridge the gap to increase our consciousness, to show us things that we never thought were possible, things that we can now put on a set of virtual reality glasses, and we can walk through a power plant, we can walk through a refinery and visualize data that our eyes normally couldn't see, visualize conditions. And so things that used to be Star Trek are now reality. It's now all possible. And when we show these young kids that these are possible, the things that are in the space sector, we increase their motivation to learn, but we also increase their chances of success in thinking outside the box. And so I think that's one of the burning questions that that can be answered by getting investors on board, by getting stakeholders with the resources to enable entrepreneurs and startups to engage the educational sector better, because it's one of the sectors that are left behind. We talk about research, we talk about making machines smarter, and we talk about AI. We need to use machine intelligence to make us smarter. We need to use the things that have been developed in space to make us as human beings smarter and extend our consciousness. And that's something that we're seriously looking at addressing in a concrete manner at the WBAF.
That was really good news, and I totally see the need for sort of developments in that realm. And when we're talking about collaboration, having some of those actors come together to understand where the real problem is and how we can go about solving it. You mentioned sort of collaboration between governments in this case and sort of the education sector, which I think is highly needed.
There's a huge opportunity there.
Absolutely, absolutely. I just would like to mention for people in the audience here, we've got like a few minutes left. If you have any questions, feel free to just write them down in the chat, or we can also get them straight from our main organizers, but make sure that you drop them there if you've got any burning questions for our panelists. Before we wrap up, I would like to go to you, Parya. You've talked a little bit about some of those applications when we were having a chat previously, and sort of what are the applications that are most desirable to come from space tech that we would actually want to have on Earth. So with that sort of one foot in academia and in the private sector, where you sort of help to co-create some of those solutions, what are some of the hot topics that you see out there and applications that we could use?
So the applications that general public can use, you mean?
Yeah, well,
like what do I miss?
Both of those things, actually.
Both of those. So I think that at the moment, the biggest challenge, or one of the big challenges we have in the space industry, or at least on the downstream side, is that the technology, method, data, they are quite advanced, but the uptake is not yet enough. So we put quite a bit of emphasis also, as Alex also mentioned, on capacity building and education and increasing awareness. Like the European Space Agency has quite a bit of programs about going out there and bring space data into the actual stakeholders and teach them how to use it and show them the added value, or show them the hidden value that they can actually obtain and how they can make their work more efficient and make better decisions. So that's still not there enough. So that needs quite a bit of still working to really like use the full potential of the satellite data or space technologies, what it can offer. But then there are also these like very exciting but kind of far-fetched things that at the moment they are being studied. For instance, like stuff that seems quite crazy is like measuring the nutrition value of crops using satellites. So that can be done already to some extent. You can already measure from the very baby plant what is the nutrition value, and that is like the hidden hunger is basically a very, very important but neglected topic in the whole food security discussion. Also, like what you can do with climate mitigation. Like, okay, there are acts for controlling climate change, but also what can you change in your practices to be prepared for the coming climate change? So how the farmers should use better practices according to what's going to come next. I think these are where there's still quite a bit of potential to be explored and used. But I'm not going to get into like, okay, like we can also extend it to health issues and water pollution and measuring the indicators in water more and see how the disease is spread, because those are also things that scientists are looking into. But that's, I think, a little bit too far.
Yeah, we'll probably come back to that. Maybe we'll ask some of the students to reach out to you if they want to explore that part. And
please do, yes.
Absolutely. We'll make sure that Victoria can sort of share all the details for those of you who are interested. There's one question that came in here that I'd like to address. So indeed, space techs can help to solve many problems on Earth, but we also risk to litter up the Earth orbit with garbage objects. Is this considered as a big problem? And are there any effective solutions to this? I see people smiling. Who would like to take that one? Alexander?
Yeah, I can jump in on that because actually when I was working at the European Space Agency, they just started including this in the program plan. Like when launching a satellite mission, you have different stages. Unfortunately, for a long time, they didn't have a stage for what happens with the satellite after it's operational. But now it's being basically included. So you basically have to deorbit a satellite either for it to fall back into the atmosphere or to basically go into a graveyard orbit where it's not going to be affecting any other satellites in the near future. Nevertheless, we've seen over the last years also like collisions, and the collision actually leads to like several of thousand little new objects, which again, like it's just a domino effect. But yeah, suddenly again, like a problem becomes an opportunity, and now you have the first kind of deorbiting kind of space startups which want to have deorbiting as a service. So actually, again, like kind of utilize old satellites, patch them together for new ones. So again, it sounds very science fiction, but that's how it starts. And the moment also the European Space Agency and the European Commission opens up grants for development for that, then that becomes strategic and that becomes a reality at one point. Besides that, of course, there's a lot of drone innovation happening, like there's high altitude pseudo satellites, something between the typical drones and the satellite Earth observation. There's also new cool technologies appearing, which gives you a higher spatial resolution and like more locality. So yeah, those things are being taken care of so that Earth observation doesn't become negatively annotated with littering in the future.
Great. I guess that's the answer we were hoping for, right? Like that's going to be taken care of. I see that we're going to have to wrap up in a minute. So I'd like to close off with a last question to all of you. So very quickly, if you could all have a gigantic billboard anywhere with anything written on it, so metaphorically speaking, getting a message out to millions or billions of people, what would it say and why? Alexander, do you want to start?
Actually, I have two. the first thing, like maybe such a global billboard wouldn't be of help. I think this locality part of having the right information to the right people at the right moment and at the right time, maybe that's going to be even more needed. It's like curated content for people who really need it. But the other key message is to also reflect of that a lot of applications we're working on are still trapped in destructive economics. So you haven't touched this object of like, I've seen a lot of really cool organizations starting, but then like accepting venture capital and suddenly shifting away from their initial purpose. So we have to figure out on which fundament are we actually building. And if it's rotten, we shouldn't start there. So the key message also here, that you have a choice of like, where do you start for what kind of organizations or what kind of organization you want to build. I think that's really important.
Great. Angela, what about you? What would be the message?
I would simply say it takes all kinds of people. So I think the tech industry should include more minorities and to use all the creativity and smartness we have to solve the challenging problems.
Great. Cornelius, what will be your billboard?
So if I were to place a billboard up, I think just mainly because of COVID-19, I would say ask yourself what is important for your ideal living environment and working environment.
Okay. And Parya, what would you like to close off with?
I would like to, if I could tell people something, I would want to emphasize that any action they take as an individual for protecting the environment matters, and that we don't need few people to do it perfectly fine, recycling perfectly fine, doing everything like carbon neutral, but we need millions and billions of people who are doing it imperfectly, but they're doing something. That would be something I would like to emphasize.
Thank you. I love closing on this. Every action matters, no matter how small. You can all add your part to create a more sustainable world, a more sustainable planet. I think this is a beautiful message to end with. So thank you so much for that. Very much appreciate all of their time and the insights that you've shared today. We'll make sure to be able to connect with some of the panelists that would have further questions later on. But thank you very much for being here with us today. And I guess I'll pass it back to the main stage.
Thank you so much. Thank you to the panel and also to Sebastian for moderating this session. Very interesting to hear. And I look forward to seeing all those billboards located in all the beautiful cities in the world. Thank you so much for your time today.